Waiting for Mom. I think I'm gonna play no Zelda today. Who knows how long I'll fulfill that promise?
That's fine. And let's say another statement, psi. And we want to say that both of them fall at the same time. So normally you'd say phi and psi. So we use this small wedge, say and. So this means phi holds and psi holds.
So what does that actually mean? Give me a practical example.
So for example, we want to say 3 is a prime number and 3 is odd. You will write this down.
Yikes, I should level 11 this at least. What the heck, that sucks.
3 is odd. And then you can put
That
this
is super cringe.
thing to say both of those things are true. Now, let's say that you want phi and psi.
Maybe I should level 90 so gross.
Maybe one of them's not. Maybe both are true. But at least one of them. So this is all. And you split the wedge. So for example, it's raining or it's not raining. One of them is true, the other is not. As a whole, the statement is true.
In that case, the two, only one can be true.
That's right.
But you told me when I used that symbol, that down wedge, or one of they could both be true.
Yes.
Also, it could be it's raining and the sun's out.
For example, that's a good example, right? That's how you get the English.
Is there a symbol where only one can be true?
So, on this list, that would be this plus. Actually, wouldn't use that. We don't use that as much in math. So, in those cases, no, you just spell it out and you say exactly one of those things is true. But in computer science, for example, if you understand logical operation, exclusive OR, right, or XOR, is exactly this. Only one of those is right. Let's do negation. Let's say that something is false. So the fact that it is false is a true statement. We want to say this is not true. So 2 is not an odd number. So it's odd being the only even prime, but it's not an odd number. So this is this little upper bracket, I guess. Sometimes people use this tilde symbol. This is phi is false. Let's talk about implications. So the idea of implication is maybe a little bit confusing sometimes outside of mathematical, well, outside of any math. We just use this arrow, meaning that if phi is true, then psi is true. Now, it tells you nothing about the truth of phi, and it tells you nothing about the truth of psi. All it tells you is that if this is true, then this is true. If it's raining, take an umbrella. It tells you nothing about whether or not it's raining.
Can you give me a more mathy example?
If the number is even, then it is not odd. Yeah. This double arrow just means this and also the other direction. So this is phi implies psi and psi implies phi. So this is true exactly when that is true.
How's that different from the first one?
So the first one just tells you that if phi is true, then psi is true. If it's raining, take an umbrella. I took an umbrella tells you nothing about whether or not it's raining. In this case, I take an umbrella if and only if it's raining.
So if I see someone with an umbrella, I know it's raining.
Exactly.
Okay. Yeah. So in this case, with that single arrow, phi has all the power.
Kind of, yeah. It's a stronger condition, right? You know phi, then you know psi. Now, what about these double ones? Well, here it gets slightly more complicated. We write this, indicate a statement about statement. All we've done here is part of the language of mathematics. And so if I want to write a formal statement, this is what I use. Now, I want to make a statement about those statements. Right, so for example, in some context, this would be true, then in that context, this would also be true. So this is called...
Witness the power of animal hypostasis. Have fun with this gas. Too late for it. Choke fraud. Hold that pose.
And those working in, say,
Absorption test. Dare to mess with me? Rain cutter. Super keeps its course. Animal test 6308. Swirl, Mark 2.
It's kind of hard to explain that without going into
Say cheese. Breaking news. Too late for it. Absorption test.
statement. On that, this is why I want to try to go to the final.
No, my sword. Stand clear. Have fun with this gift. Dare to mess with it. Let me weave you a verse. Smile. Hard-hitting explosive.
Any number
Absorption test.
for all x is greater than
Wait, says this was stronger.
1, then x is greater or equal than 2. Then you can take this statement and interpret it in a
Even if
context. For
she does get
example,
elemental
natural
mastery, big deal. That'll
number.
increase
So for any x
Shang-Chu's
greater than 1,
damage
greater or
instead,
equal
which is
to
still
2.
good,
That's true. Right? If you
technically.
consider the rational number,
Although this is a freeze team, so
tells you that this thing is false.
the M is still
Similarly, you can
not
say
very
that
ideal.
there exists an x such that whatever, right? That x
Animal
plus
hypostasis. Gears of the storm.
So there exists x such that x plus itself equals
Time to act.
again falls in the natural number.
Rain outlines its fate. Huh? Rain. Animal test 6308.
Yes,
Absorption test. Tap.
exactly like saying it outside.
Correct. Hold that pose.
You need to check and understand if you have where is outside. Right? Are we in England? Are we in Morocco? Are we in Brazil? All those places may or may not be raining. What's the aim of the line, bro? So this just
Swirl. Mark 2. Super keeps its course.
Well, this is
No, my
something that
sword.
speaks less
Let me
of
weave you a
motion
verse.
because it's just negation. Okay, we can talk about
Rain outlines it.
Alright, we'll come back to those other logic symbols another time. People request it.
Yeah.
Do another piece of paper. Maybe a piece of paper.
Okay, let's talk about symbols from set theory. So first of all, what's a set? Just like the number 3 is the mathematical expression of how many fingers are holding up. A set is the
Absorption
concept of
test.
being set. So you can think of the collection of all the books on your shelf, or all the rocks, or all the other available things that you have in your office.
Time to act.
Mathematics.
Yes.
A set. Obviously a set
Say
is a collection
cheese.
of books, and it's not a collection of rocks. Right. Is the set always a collection of
No, my sword.
That's a great question.
Tap.
Sets are collections of
clear.
mathematical objects because they itself being mathematical objects.
Yes.
What's a mathematical object? Could it also be polygons or...
Yes. So a mathematical object is simply something that we think of as an abstract idea that you can find in mathematics. It could be a number or a function or a number field or a collection of vectors or anything. Right, so the first one is the empty set. Now, a lot of people would think that this is a phi, which is a Greek letter, but it is in fact a letter in the Danish alphabet, which I'm not even going to try and pronounce, because I will get done with that in the comments. It was introduced by, I think, Uki in the 1930s, simply as a simple way of writing something simple. Before that, there were other symbols. I don't remember. So what is the empty set? It's simply a set that has no elements.
But it's not zero.
It's, well, 0 is a number. Now, you may recall another video where you can think about numbers in terms of sets. And you can think of this as being 0 You can think of 0 as just a representation of how many elements, how many members are in this set.
So, each set is not no set.
Exactly.
Absorption test.
Common analogy is this
Stand
analogy
clear.
breaks down your set. Upstairs is different from set with bag, then stuff. Empty bag is not a good bag.
Absorption test.
Heading out to the
Know my
supermarket,
sword.
have an empty bag.
Rain outlines your
Have that.
fate.
I guess this analogy will break down as soon as you move from that. Let's do this. So if we have A and B are two sets, and we look at that, so this is the set difference. So this means the part of A that is not in B. What does that even mean?
Is it the same as minus? Is that minus?
Yeah, exactly. It's A minus B. So you can think of sets as being some kind of an abstract property.
So if A was all the prime numbers
Mhm.
and B was all the odd prime numbers,
Mhm.
2 is in bag A, it's not in bag B.
Yes.
So is the difference there 2?
Is the set whose only element is 2.
Right.
Yes. Yeah. Exactly. That's a very good. Very good.
The result of this, after I do the calculation or the working out, is a new set
Yes.
with a bunch of things in it. That is the difference.
Exactly. And the difference could be empty,
If they're the same.
or if maybe B was larger. Right. Take A to be the set of prime numbers, B the set of all numbers. If you remove all numbers from all the prime numbers, you get nothing. Right. So then you have this little C over here. Sometimes people use like that. Now, this is used more in introductory classes. Once you move on, more advanced set theory is kind of this meaning and becomes different. And we already have so many things in this kind of exponentiation. So don't really use that in research. But it means the part outside. So it's all the things that are not.
That could be pretty. I mean,
Could be pretty big.
is it not always infinite?
Well, it depends on the context. Right? This is why we don't use that in actual research. Because
Give me an example.
yeah, so if you say my interest right now is just an atom. That's it. Then if you look at all the odd numbers and you look at the complement, then everything that's not an odd number is
Even number. Right.
the set of even numbers. Exactly.
Okay.
So that would be everything outside. But that depends on what is the context, what is the whole set we're dealing with right now. Okay, let's do these guys because they're actually analog of what. So this is called an intersection.
Enhanced animal model. Witness the power. Good one.
And symbol, consider
Have fun with this game.
and in very old notation it was that
Breaking news.
this is
Stay clear.
One
Glasses.
second. What would you say about that?
Say cheese.
So, for example,
Here's of the store. Swirl. Mark 2. All things that are in this one of those. Everything Too late for regret. Smile.
So if A was the even numbers and B is the odd numbers, the result would be the natural numbers. Is that?
So now,
He's stuck.
let's say that you want to say what is in
Dare to mess with me. Stay clear. Absorption test.
Subset.
Does that mean that everything in A has to be somewhere in B?
Exactly. Exactly what it is. This is a notation that is kind of very I'm not going to say defies it, but there are some strong opinions of this. So if you have this small line down here, it's kind of like less of, so it allows the
I'm in danger.
Yeah. So suddenly, everything that is okay,
Truth repeats its course. Truth bomb!
then you can have
Hold that pose!
without
Brain
that,
cutter!
and possible,
No, my soul!
say, oh,
Animal test 6308. Animal hypostasis emulation.
A B, so they has to have the line. Yes. But
Say cheese!
say no, just the same. So,
Absorption
what I
test.
normally do is you add this, say no, this is a state concept. So you add this line, so this would be here.
So if
Another
Asa
one
has
lower.
got an extra line in there, he's saying to me,
It keeps telling me to go lower.
B must be bigger than A. A is a smaller thing.
Yeah.
Enhanced animal module.
And then
Body
you can
witness the power of
on
Gugwa.
the subject.
Brain outlines your fate.
Okay.
Breaking news! Hold that pose!
So for us, that
Animal test
there is
6308.
something in A that is not in B. Exactly.
Very good. To be a satirist.
Now I've been on that.
The last one we're going to talk about here is going to be this, and the negation of it. So this is actually not a connection between sets, but between something and a set. So when I write that small a
Time to act now. No, my soul!
is simple,
Say cheese!
so this is a method. And the k is so for example, k is a method of the set of prime numbers, also of the set of odd numbers, and many other sets. Now you can put this line to say this is not true, so A is not a member of A.
So 4 is not a member of prime numbers.
Exactly.
Hold that pose!
Let's talk about some examples.
Brain outlines your fate. No, my soul! Stay clear! Ta!
And with any
Absorption
equation, just
test.
like that right for A is has a different name or even maybe a different meaning in different languages, these two might be used in a non-standard way in different fields of mathematics. But here's how the common kind of most.
This is how you use them anyway.
Yeah, well, actually, no. This is called blackboard bold font. Because I'm guessing used to indicate a bold-based letter on the blackboard, so it's kind of harder. Although, we just break off a piece of chalk and inside it, but
Too late for regret. Say cheese! Brain outlines your fate. Stand clear. Absorption test.
that,
If only I stumbled upon lab supplies as often.
Not big a deal.
now, I think I've said it last time, there's a point of contention whether or not 0 is a natural number. It is. Let's just put it out there. But in some context, it's easier to omit it. Next, we have this blackboard set, and where you are in the world. And this is the set of integers, so that 0 and 1, minus 1, 2 and minus 2, and so on in both directions. So this is all the whole numbers. Next we have Q, again blackboard bold, which is the rational numbers. So these are ratios of integers. So this is 1, which is 1 divided by 1, again 1 half, and 9,
What's 1/3?
same thing.
Okay.
So 7 halves, which also known as 10 half. Okay, yeah.
But not the square root of 2.
Not the square root of 2. To get that, we go to real numbers, which is the blackboard font with R. So these are the real numbers. And these include things like pi, e, square root of 2, many other numbers. And one number they don't include is I, which is the imaginary unit, square root of minus 1, or A, square root of minus 1. After that, you go to C, again, but we'll go, which is the complex numbers. You have here a few letters. Use are left a lot. That
Why?
has the slight meaning.
Did you not activate your paraglider, you stupid fucking idiot?
What about these? A whole other video.
Aleph will actually feature heavily in a whole other video with NASA, which is coming very soon. It's all about absolute infinity, so stay tuned or subscribe for that. Also, have a look at the links in the video description for more videos, podcasts, and links relating to this work.
Size of how many types gets well over off the left.
But it's not all the different ways you can rearrange them. It's not itself.
No, that is actually 2 to the other block.
Top 3 reasons why that's the best section.
This is a video about the oldest unsolved problem in math. It dates back to 2,000 years. Some of the brightest mathematicians of all time have tried to crack it, but all of them failed. In the year 2000, the Italian mathematician Pier Giorgio Odefreddi listed it among 4 of the most pressing open problems at the time. Solving this problem could be as simple as finding a single number. So mathematicians have used computers and checked numbers up to 10 to the power of 2,200. But so far they've come up empty-handed. Why do you think this problem has captured the imaginations of so many mathematicians? It's old, it's simple, it's beautiful. What else could you want? So the problem is this. Do any odd perfect numbers exist? So, what is a perfect number? Well, take the number 6, for example. You can divide it by 1, 2, 3, and 6. But let's ignore 6 because that's the number itself. And now we're left with just the proper divisors. If you add them all up, you find that they add to 6, which is the number itself. So numbers like this are called perfect. You can also try this with other numbers, like 10. 10 has the proper divisors 1, 2, and 5. If you add those up, you only get 8. So 10 is not a perfect number. Now you can repeat this for all other numbers, and what you find is that most numbers either overshoot or undershoot. Between 1 and 100, only 6 and 28 are perfect numbers. Go up to 10,000 and you find the next 2 perfect numbers, 496 and 8,128. These were the only perfect numbers known by the ancients, and they would be the only known ones for over 1,000 years. If only we could find a pattern that leads these numbers, then we could use that to predict more of them.
Why do I keep getting elemental mastery?
Well, one thing to notice is that each next perfect number is 1 digit longer than the number that came before it. Another thing they share is that ending digits all fix between 6 and 8. Also means they are all even. But here's where things get really weird. You can write 6 as the sum of 1 plus 2 plus 3, and 28 as the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and so on for the others as well. They're all just the sum of consecutive numbers. And you can think of each additional number as adding a new layer. And so these create a triangle, which is why these numbers are called triangular numbers. Also, every number except for 6 is the sum of consecutive odd cubes. So 28 is 1 cubed plus 3 cubed. 496 is equal to 1 cubed plus 3 cubed plus 5 cubed plus 7 cubed. And 8,128 is equal to 1 cubed plus 3 cubed plus 5 cubed plus 7 cubed plus 9 cubed all the way up to 15 cubed. Here's the one that really blows my mind. If you write these numbers in binary, 6 becomes 110, and 28 becomes 11100. 496 becomes 1111100, and 8128, you guessed it, it is also a string of ones followed by a series of zeros. So if you write them out, they are all just consecutive powers of 2.
What's that?
Now, around 300 BC, Euclid was actually thinking along similar lines when he discovered the pattern that makes these perfect numbers. Take the number 1 and double it. You get 2, now keep doubling it. You get 4, 8, 16, 32, 64, and so on. Now, starting from 1, add the next number to it. So 1 plus 2 equals 3. If that adds up to a prime, then you multiply it by the last number in the sequence to get a perfect number. So 2 times 3 equals 6, the first perfect number. Now let's keep doing this. Add 1 plus 2 plus 4 and you get 7, which is, again, prime. So multiply it by the last number, 4, and you get 28, the next perfect number. Next, add 1 plus 2 plus 4 plus 8 equals 15. But 15 isn't prime, so we continue. Add 16 to get 31. This is prime. So you multiply it by 16 and you get 496, the third perfect number. Now you can keep doing this to find bigger and bigger perfect numbers. And using this, we can rewrite the first 3. So 6 equals 1 plus 2 times 2 to the power of 1, and 28 equals 1 plus 2 plus 4 times 2 squared, and 496 equals 1 plus 2 plus 4 plus 8 plus 16 times 2 to the power of 4, where the first term is prime. But there's a more convenient way to write this still. Take any sum of consecutive powers of 2. So 2 to the power of 0, which is 1, plus 2 to the 1, plus 2 to the 2, all the way up to 2 to the n minus 1. And now, because you don't know n, you don't know what that's equal to. It will be equal to something, so let's call that t. Now, multiply this whole equation by 2. So you get 2 to the 1 plus 2 to the 2, all the way up to 2 to the n, and this is equal to 2t. If you now subtract the first equation from the second, almost all the terms will cancel out, and you're left with t equals 2 to the n minus 1. So you can replace this whole series with one less than the next power of 2. So 6 becomes 2 squared minus 1 times 2 to the 1, 28 becomes 2 cubed minus 1 times 2 squared, and 496 becomes 2 to the 5 minus 1 times 2 to the 4. Do you see the pattern? This number is always one more than this. So if we call this p, then Euclid's formula that gives the perfect number is 2 to the p minus 1 times 2 to the p minus 1, whenever this is prime. Now, because you're multiplying it by 2 to the p minus 1, which is even, this will always give an even number. Euclid had found a way to generate even perfect numbers, but he didn't prove that this was the only way. So there could be other ways to get perfect numbers, including potentially ones that are odd. 400 years later, the Greek philosopher Nicomachus published Introductio Arithmetica, the standard arithmetic text for the next 1,000 years. In it, he stated 5 conjectures, statements he believed to be true, but did not bother actually trying to prove. His conjectures were: 1. The nth perfect number has n digits. 2. All perfect numbers are even. 3. All perfect numbers end in 6 and 8 alternately. 4. Euclid's algorithm produces every even perfect number. And 5. There are infinitely many perfect numbers. For the next 1,000 years, no one could prove or disprove any of these conjectures, and they were considered facts. But in the 13th century, Egyptian mathematician Ibn Fallas published a list with 10 perfect numbers and their values of p. 3 of these perfect numbers turned out
How do I
not to
unlock
be perfect
this?
at all, but the remaining ones are. The 5th perfect number is 8 digits long, which disproves Nicomachus's first conjecture. And the next thing to notice is that both the 5th and 6th perfect number end in a 6. So that disproves Nicomachus's third conjecture, that all perfect numbers end in a 6 or 8 alternately. 2 conjectures were proven false, but what about the other 3? 2 centuries later, the problem reached Renaissance Europe, where they rediscovered the 5th, 6th, and 7th perfect numbers. So far, every perfect number had Euclid's form. The best way to find new ones was by finding the values of p that make 2 to the p minus 1
Can I go
prime.
take a look?
So French polymath Marin Mersenne extensively studied numbers of this form. In 1644, he published his results in a book, including a list of 11 values of p for which he claimed they corresponded to primes. Numbers for which this is true are now called Mersenne primes. Of his list, the first 7 exponents of p do result in primes, and they correspond to the first 7 perfect numbers. But for some of the larger numbers, like 2 to the 67 minus 1, Mersenne admitted to not even checking whether they were prime. To tell if a given number of 15 to 20 digits is prime or not, all time would not suffice for the test. Mersenne discussed the problem of perfect numbers with other luminaries of the time, including Pierre de Fermat and René
Let me
Descartes.
read you a
In
verse.
1638, Descartes wrote to Mersenne,
Animal hypostasis emulation. Absorption
numbers
test.
except those of Euclid. He also believed that if an odd perfect number does exist, it must have a special form. It must be the product of a prime and the square of a different number. If he was right, these would easily have been the biggest breakthroughs on the problem since Euclid, 2,000 years earlier. But Descartes couldn't prove either of those statements. Instead, he wrote, "As for me, I judge that one can find real, odd, perfect numbers. But whatever method you use, it takes a long time to look for these." Around 100 years later, at the St. Petersburg Academy, the Prussian mathematician Christian Goldbach met a 20-year-old math prodigy. The two stayed in touch, corresponding by mail, and in 1729, Goldbach introduced this young man to the work of Fermat. At first, he seemed indifferent, but after a little more prodding by Goldbach, he became passionate about number theory, and he spent the next 40 years working on different problems in the field. Among them was the problem of perfect numbers. This prodigy's name was Leonhard Euler. Euler picked up where Descartes had left off, but with more success. In doing so, he made 3 breakthroughs on his problem. First, in 1732, he discovered the 8th perfect number, which he had done by verifying that 2 to the 31 minus 1 is prime, just as Mersenne had predicted. For his other 2 breakthroughs, he invented a new weapon, the sigma function. What the function does is it takes all the divisors of the number, the number itself, that's the
No,
number.
my sword.
Take
Ray
any number,
outlines
say
your
6.
fate.
Sum
Ring
up
cutter.
all its divisors,
Animal
and you
test.
get
Keep
12.
me away.
There's twice the number you started.
We'll see about that.
For all perfect numbers.
Absorption
The sigma
test.
function of a perfect number will always give twice the number itself, because the sigma function includes the number as one of its divisors. Now, this may seem like a small change, but it ends up being extremely powerful. So let's look at a few examples. Pick a prime number, like 7. Now, because it's prime, you can't rearrange it into a
I'm
rectangle.
just right back to where
Therefore, the only divisors are 1 and the prime itself. So sigma 7 is 1 plus 7, which is equal to 8. Now, to keep things easier to follow, we'll just stick to the numbers. But what if instead of 7, you had 7 cubed? Well, again, the sum of the divisors is really simple. It's just 1 plus 7 squared plus 7 cubed. Now let's use it on a different number, say 20. The sum of its divisors is 1 plus 2 plus 4 plus 5 plus 10 plus 20, which equals 42. You can also write this as 1 plus 2 plus 4 times 1 plus 5. And this is what really makes the sigma function so powerful. If you have a number that is made up of other numbers that don't share factors with each other, then you can split up the sigma function into the sigma functions of the prime powers that make it up. So sigma 2 squared times sigma 5 is equal to sigma 20. And since any number can be written as the product of prime powers, you can split up the sigma function of any composite number into the sigma functions of its prime powers. With this new function in hand, Euler achieved his second breakthrough and did what Descartes couldn't. He proved that every even perfect number has Euclid's form. This Euclid-Euler theorem solved a 1600-year-old problem and proved Nicomachus's fourth conjecture. Math historian William Dunham called it the greatest mathematical collaboration in history. But Euler wasn't finished yet. He also wanted to solve the problem of odd perfect numbers. So for his third breakthrough, he set out to prove Descartes' other statement, that every odd perfect number must have a specific form. Because if an odd perfect number does exist, you know two things. First, n is odd, and second, sigma of n equals 2n. Now, any number n you can write as a product of different prime numbers, and each prime will lead to some power.
Body
So
and
let's take that and put it into Euler's sigma function. So you get sigma of n equals sigma of all of those primes to their powers, which equals 2n.
Witness the
Since
power
all of these
of
factors are primes, you can actually split up the sigma function into the sigmas of the individual prime powers. Now, one thing to notice is that if you have a prime number raised to an odd power, for example 7 to the power of 1, then the sigma function will be even, because 1 plus 7 equals 8. You'll always get an even number because odd plus odd is even. If the prime number is instead raised to an even power, like 7 squared, then the sigma function returns an odd number. Sigma of 7 squared equals 1 plus 7 plus 7 squared, which equals 57. Because odd plus odd plus odd equals odd. So if you have the sigma function of an odd prime raised to an odd power, it will give an even number. If instead it's raised to an even power, you get an odd number. And this is where Euler's
random
genius
events don't
insight
count.
comes in. Because here on the right side, you've got 2 times n, where n is an odd perfect number, and 2 is even. Well, what that means is that on the left side, there must only be one even number. Because if there were 2 even numbers, you could factor out 4. But that means you should also be able to factor out 4 on the right side. But you can't because n is odd. There's
Let me
only a
read you
single
a
2
verse.
here.
Brain outlines
So
your
only
face.
one
No,
of these sigmas here give
Too late for
a
it.
number.
Absorption
Which means that there's exactly one prime that is to an odd power, and all the others must be to an even power, just as Descartes had predicted. Now Euler refined the form a bit more and showed that an odd perfect number must satisfy this condition. But even Euler couldn't prove whether they existed or not. He wrote, "Whether there are any odd perfect numbers is a most difficult question." For the next 150 years, very little progress was made, and no new perfect numbers were discovered. English mathematician Peter Barlow wrote that Euler's 8th perfect number is the greatest that ever will be discovered, for as they are merely curious without being useful,
Enhanced
it
animal
is not
life.
likely that
Ears
any
of the
person will
storm.
ever attempt to find one beyond.
Safe. Ring cutter.
But Barlow was wrong. Mathematicians kept pursuing these perfect numbers, and most started with Mersen's list of proposed primes. The next on his list was 2 to the 67 minus 1. So far, Mersenne had done an excellent job. He had included Euler's 8th perfect number, while avoiding others, like 29, that turned out not to lead to a perfect number. But 230 years after Mersenne published his list, Edouard Lucas proved that 2 to the 67 minus 1 was not prime, although he was unable to find its factors. 27 years later, Frank Nelson Cole gave a talk to the American Mathematical Society. Without saying a word, he walked to one side of the blackboard and wrote down 2 to the 67 minus 1 equals 147 quintillion, 573 quadrillion, 952 trillion, 589 billion, 676,412,927. He then walked to the other side of the blackboard and multiplied 193,707,721 times 761,838,257,287, giving the same answer. He sat down without saying a word, and the audience erupted in applause. He later admitted it took him 3 years working on Sundays to solve this. A modern computer could solve this in less than a second. From 500 BC until 1952, people had discovered just 12 Mersenne primes, and therefore only 12 perfect numbers. The main difficulty was checking whether large Mersenne numbers were actually prime. But in 1952, American mathematician Raphael Robinson wrote a computer program to perform this task, and he ran it on the fastest computer at the time, the SWAC. Within 10 months, he found the next 5 Mersenne primes, and so corresponding perfect numbers. And over the
I
next
don't have a lot of
50 years,
convenient
new
pyro.
Mersenne primes were discovered in rapid succession. all using computers. The largest Mersenne prime at the end of 1952 was 2 to the power of 2,281 minus 1, which is 687 digits long. By the end of 1994, the largest Mersenne prime was 2 to the power of 859,433 minus 1, which is 258,716 digits long. Since these numbers were getting so astronomically large, the task of finding new Mersenne primes became more and more difficult, even for supercomputers. So, in 1996, computer scientist George Wolfman launched the Great Internet Mersenne Prime Search, or GIMPS. GIMPS distributes the work
We
over
can definitely write this
computers,
off as
allowing
incidental
anyone to
Wait, so the name of an ARC program is...
for Mersenne primes. The project has been highly successful so far.
My god, I never knew that program was so nerdy.
15 of which were the largest known primes at that time. And the best part? If your computer discovers a new Mersenne prime, you'll be listed as its discoverer, adding yourself to a list that includes some of the best mathematicians of all time. There's even a $250,000 prize for the first billion-digit prime. In 2017, church deacon John Pace discovered the 50th Mersenne prime by using GIMPS. The number, 2 to the 77,232,917 minus 1, is more than 23 million digits long, and it was also the largest known prime at the time. To celebrate this achievement, the Japanese publishing house Nanai Rosha published this book, The Largest Prime Number of 2017. And all it is that number spread over 719 glorious pages. It's wild. The size of this font is so tiny. The book quickly rose to the #1 spot on Amazon and sold out in 4 days.
What?
A year later, the
People bought a book that just had random numbers in it.
It's 2 to the 82,589,933 minus 1. And this number has 24,862,048 digits. There's something I enjoy about the absurdity. Like, there's knowledge in here, but it's not the kind of knowledge that anyone's ever going to read in the book. But in some ways, it's nice that there's this physical artifact that has the number. If ever we lost all the prime numbers, someone could find this book and be like, here's a big one. As of today, it's still the largest known prime. And since numbers of this form grow so rapidly, the largest Mersenne prime is almost always the largest known prime. Computers have been incredibly successful at finding new Mersenne primes and their corresponding perfect numbers. But we've still only found 51 so far. So you might suspect that there are only a finite number of them, which would mean that Nicomacheus's fifth conjecture would be false, that there aren't infinitely many perfect numbers. But that might not be the case. The Lenstra-Pomerantz-Wettestaff conjecture predicts how many Mersenne primes should appear based on how large P is. Now, this is the actual data. The conjecture performs remarkably well, but more importantly, it predicts that there are infinitely many Mersenne primes, and so infinitely many even perfect numbers. The Mersenne primes are just so large and rare, they take a lot of time and computer resources to find. But a conjecture is not a proof, and up until this day, this problem shares the title of oldest unsolved problem in math with the other open problem: do any odd perfect numbers exist? The easiest way to solve this problem is by finding an example. So maybe we could just check different odd numbers and see if one of them is perfect. That's exactly what researchers tried in 1991. By using a smart algorithm called a factor chain, we were able to show that if an odd perfect number does exist, it must be larger than 10 to the power of 300. 21 years later, Pascal Bochum and Michael Rao raised that lower bound to 10 to 1,500. With recent progress pushing that number up to 10 to 2,200. With numbers that large, it's unlikely that a computer will find one anytime soon. So we'll need to get smart.
What would a proof look like? Like, how could we actually prove this?
I think the main idea that people have been trying to approach this problem with is coming up with more and more conditions odd perfect numbers have to satisfy. It's called this web of conditions, where it has to have 10 prime factors now that we know, and maybe thousands of non-distinct prime factors. It has to be bigger than 10,000. It has to do all these different things. And we hope that eventually there's just so many conditions they constrain the numbers so much that they can't exist.
Since Euler, mathematicians have kept adding new conditions to this web.
But so far it hasn't worked.
There might be another path. When Descartes was looking for odd perfect numbers, he came across 198,585,576,189, which you can factor as 3 squared times 7 squared times 11 squared times 13 squared times 22,021. Put this into Euler's sigma function, and you find it is equal to 2 times the original number. In other words, it is perfect. That is, if 22,021 were prime. But it's not, because it is equal to 19 squared times 61. And filling that in shows that it is not perfect. Numbers like this, that are very close to being odd perfect numbers, are called spoofs. Spoofs are a larger group of numbers. So odd perfect numbers share all properties of spoofs and then a few extra ones. The goal is to find the properties of spoofs that ultimately prevent them from being odd perfect numbers. For example, one condition of odd perfect numbers is that they can't be divided by 105. So if you find that spoofs must be divisible by 105, then this would prove that odd perfect numbers can't exist. In 2022, Pace Nielsen and the team at BYU found 21 spoof numbers, including Descartes.
Over here!
And while they discovered some new properties of spoofs, they find that rule out odd perfect numbers. So, how large would an odd perfect number have to be?
They don't exist.
You don't think odd perfect numbers exist?
No, they don't exist. I wish they did. That'd be really cool. If there was just this one gigantic odd perfect number out in the universe, they don't exist. No.
How are you convinced that they don't exist?
There's something called a heuristic argument, where it's not a proof, so if we had a proof, we'd be done. It's just an argument from, okay, if you think primes occur this often of this type, put those pieces of information together, and you think, okay, on average, how many numbers should be perfect?
This argument, which was made by Carl Pomerantz, predicts that between 10 to the 2,200 n, there are no more than 10 to the negative 540 perfect numbers of the form n equals pm squared.
With odd perfect numbers, the heuristic says,
Let's appraise the
shouldn't
value on
expect
this.
we've searched high enough now that we think we have enough evidence they shouldn't exist.
My understanding is this heuristic argument, it also predicts that there are no large perfect numbers, even or odd. So,
That's true. So there's a downside. Yeah, there's a downside because it says there shouldn't be large, even perfect numbers, and we actually expect there to be infinite. Okay, so why do you want to believe it? No, okay, you're right. My being hypocritical about that. There are other aspects that are on to make it strong. You're right, it's not proof.
for now, this is still the oldest unsolved problem in math. Euler was right when he said, whether there are any odd perfect numbers is a most difficult question. So, are there any applications of this problem?
I can say no.
Now, many people may think that if there are no applications to the real world, then there's no point in studying it. Why should anyone care about some old, unsolved problem? But I think that's the wrong approach. For more than 2,000 years, number theory had no real-world applications. It was just mathematicians following their curiosity and solving problems they found interesting, proving one result after another, and building a foundation of useless mathematics. But then, in the 20th century, we realized that we could take this foundation and base our cryptography on it. This is what protects everything from text messages to government secrets.
Whenever you have a group of people put their minds towards a problem, something good's going to come out of it. If it's only at the beginning, this doesn't work. Okay, well, as Edison said, I learned 999 ways of not making a light bulb. Eventually, I got a good way to do it. It's the same with math. You have a problem and you throw your mind at it, and others do too, and you come up with new ideas. Eventually, something good comes from that process.
Einstein's general relativity was built on non-Euclidean geometries. Geometries that were developed as intellectual curiosities without foresight of how they would one day change the way we understand the universe. How many people do you think are working on the problem of perfect numbers right now?
I guess around 10 people currently have papers in the area, 10 to 15. If you're a high schooler and you just love mathematics and you think, I want a problem to think about, this one's a great problem to think about, and you can make progress, you can figure out new things.
Yeah, don't be scared. Hundreds of people have thought about this problem for thousands of years. What can I do? I can do something.
Why should you do math if you don't know that it will lead anywhere? Well, because doing the math is the only way to know for sure. You can't tell in advance what the outcome will be. Like, this problem might turn out to be a dud. We might solve it, and it might not mean anything to anyone. Or it could turn out to be remarkably helpful. The only way to know for sure is to try. In today's world, it often feels like you've got to choose between following your curiosity and building real skills you can apply. But the truth is, it's essential to do both. Fortunately, there's one learning platform which allows you to do just that, and it's this video's sponsor, Brilliant. Brilliant will make you a better thinker and problem solver by helping you build real skills in everything from math and data science to programming, technology, you name it. Brilliant has thousands of lessons for you to explore, so you can follow your curiosity wherever it leads you. And you won't just learn key concepts, you'll actually apply that knowledge to real-world situations, giving you real hands-on intuition. With Brilliant, you can learn by trying things out for yourself. That's what makes learning with Brilliant just so powerful. And along the way, you can set goals, track your progress, and level up with guided learning paths that let you go deep into specific topics. I think that learning something new every day is one of the best gifts you can give yourself, and Brilliant is the perfect way to do it, with bite-sized lessons that you can do right from your phone. So even if you only have a few minutes, you can feed your curiosity, sharpen your mind, and build new skills. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/Veritasium. Scan this QR code or click the link in the description. The first 200 of you will get 20% off Brilliant's annual premium subscription. So I want to thank Brilliant for sponsoring this video, and I want to thank you for watching.
Hey smart people, Joe here. The sun is humongous, 10 times the size of anything else in the solar system.
Surprise!
And 100 times the size of Earth. But Earth is part of a lucky cosmic coincidence. Our moon is 400 times smaller than the sun, but it's almost exactly 400 times closer to us. This means to us here on Earth, they look almost exactly the same size in the sky. Because of this coincidence, every once in a while, our tiny little moon, even though it's 400 times smaller than the sun, crosses in front of it and blocks its light from reaching Earth. A solar eclipse! On April 8th, that's going to happen right here. The shadow of the moon is going to pass right over where I'm standing. You are not going to want to miss this. The US won't see another total solar eclipse for 20 years. This is a once-in-a-generation chance to see one of the most mind-blowing events in the solar system. Today, I'm going to tell you everything that you need to know to make the most of this eclipse or any eclipse that you have the chance to see in the future. We're talking about how to pick the right spot so you can be in the maximum shadow of the moon. I'm going to give you some ideas about what to bring. Tell you everything there is to see before, during, and after an eclipse, and all the incredible things that you can learn from an eclipse, whether you're a scientist or just someone who wants to sit and feel the awe of witnessing an incredible cosmic event. First things first, if you need any persuading that this is worth seeing, well, just consider how special an eclipse is in the first place. Eclipses happen because the moon's orbit takes it between us and the sun. But the moon orbits between the Earth and the sun once a month, every time there's a new moon.
Take it easy.
So why don't we get an eclipse every month? That's because the moon's orbit is tilted a few degrees from Earth's orbital plane. Eclipses only happen when the moon's tilted orbit lines up perfectly with Earth's orbital plane between us and the sun, allowing the moon to cast its shadow on our planet. Between 2 and 5 solar eclipses fall somewhere on Earth each year, but on average, any given spot on Earth only gets one total eclipse every few hundred years. Long story short, if you have a chance to see an eclipse, you don't want to miss it. The first thing you gotta do is pick the right spot. You want to be in the path of totality. Totality is the moment during an eclipse when the moon's shadow completely covers the sun, and there's only a small stripe of Earth where you can see that. That's the path of totality on April 8th, across this stripe in North America. Now, outside the stripe, the moon will partially
I
cover
got
the
a new
sun,
letter from
but
an
you won't
informant.
see
Looks
totality.
like the situation has
Most
changed
people are in
again.
the center line, the longer totality lasts. There are tons of maps and apps to help you pick a location. I've dropped links to several down in the description so that you can look for a good viewing spot. The weather, though, that's all on you. I can't do anything about that. I'm just a scientist on YouTube, folks. Anyway, you'll want to figure out exactly what times totality will occur at your spot, so you don't have to do it on the day of the eclipse when you're freaking out from all the awesomeness. And to get the most out of the eclipse, consider an app like this solar eclipse timer, which precisely times every key moment to watch for it.
A chest full of valuables,
Not sponsoring this video or
a trove
anything.
of
It's a
potential
cool app that
clues.
really works. I'll leave you a link down in the description. I want to pause for a second and just acknowledge the fact that we can calculate this at all is absolutely bonkers. Eclipses are insanely hard to predict. Ancient people like the Babylonians, Chinese, and Maya had advanced mathematics and astronomy, good enough to construct some of the most accurate calendars in human history. But
I'm
none
in.
could predict exactly when and where solar eclipses would occur. That's not surprising, because this is one of the messiest problems in orbital
Take it easy.
physics. To predict the exact positions of the Earth, the Sun, to the future requires factoring in every little tug from every object with gravity in the solar system. We're not just solving for 3 bodies in space, it's more than a 1,000,000-body problem. Together, these wobbling, tilted orbits are the real definition of mathematical chaos. It wasn't until 1750 that anyone came even remotely close to predicting the time and place of a solar eclipse, when astronomer Edmund Halley used giant tables full of future positions of celestial bodies to hand calculate the time of the eclipse over London. He was only 4 minutes off, unless he forgot to carry the 3. These days, NASA factors in some 38,000 different overlapping orbital patterns, crunching the data with computers, letting us plan our eclipse viewing down to the second. But even with all that space for magic, NASA can only precisely predict eclipses for the next 1,000 years. It's a problem that's impossible to solve mathematically. We just hope to get close. So remember that as we plan your eclipse day down to the minute or second. The fact that we can do that at all already is an amazing thing. So relax, natural. Okay, cool. Well, next step, once you've figured out where you'll be, what time totality is, think about how you want to see it. This is where I have to remind you. Never, ever, ever look directly at the sun. I just want to say that one more time. Never, ever, ever look directly at the sun. Not if you're wearing sunglasses, not if it's 99% covered. Definitely not through a telescope or binoculars. Just don't. The first thing I'd recommend is getting yourself some cool eclipse glasses. I got these from a large online retailer named after the South American River. But you can pick them up from lots of different places, in person or online. Just do your homework and make sure you're getting the real thing. If you don't have eclipse glasses, though, there are still some really cool ways to see the eclipse.
This one's really simple and easy to make. It's a pinhole camera projector. All you have to do is poke a very small, smooth hole in a piece of paper and hold it over a light surface under the sun. Or you can go a little fancier and make yourself a little pinhole camera. Just take a box like this, trace the bottom out on a white sheet of paper, cut it out, put it inside the bottom of the box. On the other end, cut 2 notches in the lid and cover one of those with aluminum foil.
Remarkable condition.
Poke a tiny hole in there, then stand with your back to the sun, looking through the other hole, and you'll see the entire eclipse projected onto the bottom of that pinhole camera. So why does this work? Well, the light from the sun is always shooting out from all directions, but because this hole is so small, only a few rays of light make it through, traveling in straight lines. That means rays from the left side of the sun cross through the hole and hit the ground on the right side, and vice versa. What you end up with is a little flip-flop image of the sun in front of you. During the eclipse, when the moon moves over the sun, you'll see this circle turn into a crescent, smaller and smaller. So this is a safe way to watch the eclipse happen without looking at the sun. You can see the same effect using anything with tiny holes, like a colander, or even the light trickling through the leaves of trees. You can even overlap your fingers like this, leaving tiny holes in between.
Watching an eclipse is awesome even if you don't understand everything that's going on during it. But if you know a little bit about what's happening and what to expect, there's so much to see, and most of it goes by really fast. So the last thing you want to plan ahead is what you're going to look out for.
On the day of the eclipse, with your glasses on, the first thing you'll see is a tiny little nipple on the western side of the sun. Again, the solar eclipse timer app will tell you exactly what time this is going to happen wherever you're standing. As the minutes go by, the color of the sky, things around you get a little duller. The wind may even go still as the atmosphere cools inside the growing shadow. Around 10 minutes before totality, the sun will look like a thin crescent. Everything will darken. Don't take your eclipse glasses off yet. You might notice some animals acting. Horses will start shaking their heads and tails. Dogs might get anxious. Birds might stop flying or burst into their evening songs. Humans start making weird ooh or ah sounds. And in these final seconds before totality, some really cool stuff happens. Just before the last sliver of sunlight disappears, the valleys and ridges on the moon's surface cut into the crescent, leaving little beads of light that flicker along the edge of the sun just before the moon pinches them out. In 1836, British astronomer Francis Crick first recorded this phenomenon, and today, these beads of light are called Baily's beads, after him. Right before the last of these beads disappears, you'll start to see the sun's atmosphere, the corona. The sun's light covered up, wisps of the corona emerge as this faint ring around them. Then, the last bead of light pouring past the moon lights up part of the corona, creating what's called the diamond ring.
There's one last thing to look out for. Take a look at some lights that are like a skylight or white sheet. You're lucky.
You're in for a little shock.
These are shadow bands. Super things kind of look like the shadow of water or sand. They don't always happen. And the weirdest thing is, no one knows for sure why they happen. The best guess is that turbulence in the air mixes with that last narrow sliver of remaining sunlight, kind of like what makes stars twinkle.
And then, just like that, the sun is gone. Welcome to totality. Picture this. The moon's shadow falls on you. And where the sun was, there's just a black disk surrounded by glowing corona. Everything's about as bright as during a full moon. It's the middle of the day, yet some bright stars and planets are now visible in the sky.
You're in for
During totality, you take your glasses off. Cover that sun. There's some cool stuff
Hey, come a little closer.
ever see during this periods of totality. Keep an eye out for reddish cloudy shapes surrounding the disk. These are called prominences, hot clouds of gas billowing out of the sun along tangled magnetic field lines. You can actually see some of these in the first photo anyone ever took of an eclipse from 1851. The coolest thing about these prominences is that they only last for about a day. So whatever ones you see during totality are completely unique to that moment. If you can pull your eyes away from the eclipse for a few seconds, take a look around you. If you can see the horizon, you'll see what looks like a 360-degree dawn. This is the edge of the moon's shadow, visible in the distant sky, places where the sun is not totally eclipsed. A sunrise in every direction. The sky will begin to brighten as darken. The moon's shadow is the sun.
Why not keep me company for a while? There'll be plenty of time for work later. Today's no good for going out. Did I say that yesterday as well? It's nearly time for afternoon tea. Why not keep me company for a while? There'll be plenty of time for work later. Today's no good for going out. Did I say that yesterday as well? It's nearly time for afternoon tea. Today's no good for going out. Did I say that yesterday as well? It's nearly time for afternoon tea. Today's no good for going out. Did I say that yesterday as well?
You want to try her?
It's nearly time for afternoon tea.
This was never a one-on-one. You were always on his side. Background. Waiting for the perfect time to make your move. Longest combo I've ever seen. And this fall off won't even matter. I'm finished. It's all because of you. You son of a... This was my promotion, man!
But thankfully, we're fast enough so it's not able to hit us until after the race is over. And now for our 24th race, we have 3 guests who can juggle. In this one, at the start, what I want to do is get a couple of turbos, but not be able to right through. Sometimes they can send you a really weird.
Why would you fucking do that? You son of a fucking bitch.
That way we can get the flying glider, and then on those, get I almost died right there, though. That could have been bad. This music is so good. Donkey Kong music in general is so good, but other than talking about that, I have to slow down there. That way we can go to the out and get a little bit fast. But okay, we'll just keep trying to do this. We're ahead of everybody else by a good amount, and we also have 2 bananas. The problem is, anytime there's lightning, it doesn't just get rid of one of your items, it gets rid of both of your items, which is insane. Alright, of course, I want to go right there.
You're in for a little shock.
We see the golden banana, it's so beautiful. I'm not sure if the Donkey Kong is allowing us to look at all this stuff, but again, I will slow down, get a nice boost. That works out perfectly. And just one more lap. We're continuing the same sort of stuff. We honestly have not gotten to that bad of fun yet. Hopefully it will not backfire. Saying that, it feels like sometimes we just want to use the game to give you bad luck, and we do get Squidward, which isn't the best, but I'm able to go.
No pain,
and he's not
no
really
gain.
that much influence. Usually he's not, but every once in a while he will come in the perfect position to just destroy me. Like that lightning right there that almost hit me off the ledge. That would have been that. Now I think I should be good to make this again. We are tiny, which makes it a little bit harder, but perfect. And there we go. Everybody is way far behind me.
You're in for a little
Let's dance. And I love the environment of this
Come a
one.
little closer.
It's really nice that they give Wario his own stadium. You know, it's looking nice. But what I want to do here is make that. I actually did not want to do this right there. Sometimes I forget the best strategy just because it's 96 tracks, and that also could happen. It's okay. We'll do better on our second lap around. But sometimes
all I see are marks.
Every single thing you have to do, just because there's so much to remember in this round. But I do get 2 red shells. Both of them hit me. I mean, one hit my banana, the other one just hit me.
Glad there weren't any poisonous
I
mushrooms
see Donkey
inside.
Kong with that banana. He is looking at me. He's like, hey, run into this banana, why don't you? And like me too as well. I can have no friends in this game. Now he's a red shell. Donkey Kong is trying to murder me. I kind of messed up that jump. That's fine though. I'll try to do this script a little better if that's what we're actually
Try not to enjoy this too much.
Like, it is very easy to hit you. Those decks don't have any items. This is with the red shell, and then we also fall off. And still, DK, maybe you're not that bad of a guy. He's got like a super long in like 2 seconds. Was that you, DK? I think that was you. You know, my friend DK is going to continue on, at least for 5 in first place. And as soon as we get in first place, there's a blue shell. Why is the blue shell never used with someone else's? At least there's light into the blue. Not a good time. This game, like, specifically knows when I'm about to get in first place, and it's like, use it. They save it until that exact moment. I swear it has to happen. Once we go to the first place, we're somehow way ahead of the other people. I don't even know how they got that far away. But not the worst in the world. Next up, it's Game Sherbetland, and that's one of the environment. I just love snow in general. Winter, this is going to be a controversial opinion, but winter, best season. It's just so good. At least when you get snow and stuff, if it's just cold and there's no snow, it's not the best in the world. But when you get snow, winter is a top tier season. Anyways, what I want to do right here is save up a boost, and I want to use it there. And that red shell kind of scared me there. At least we dodged the red shell. I'll show you the thing we were trying to do next time. There are just a lot of the boo. Boo, really? No, he took my item for me that was protecting me from the red shell. That is so sad. The boo item is one of the funniest and one of the most aggravating items in the game, especially because I never get it. I never get to use it in a good way. But at least we can finally block this red shell, and I will be taking that right path over there. That way we can stay above ground, it's just a little bit faster, and we can get a tiny trick right off that. Now, we will get hit by a lightning, not the worst thing in the world. I should be able to take a tight
I want to use the plunge team some more.
I don't like this
But I want to keep looking at Lisa.
So we're just gonna ram the ball right there. Not too much against that. But at least we get a banana just in time to protect ourselves from that red shell. That could have been very bad. Thank you, game. It's actually doing something nice for me for once. We can hopefully get over that, but we don't. Still, not too bad. That was a very nice mistake.
Storm the front! Strength well conferred!
I really like the deck as well. Because like piano actually gets played when you go on it. It's very easy to make by these little features. So just look up fun with it. It's like you're driving around this spot man. Anyways, for this, it's pretty easy just drifting to normal places, and I will want to take that boost pad. That way we can fly.
I suppose it wasn't too much
fun. Guys, the music note guys are a little annoying. Sometimes they can jump on you or just be in an annoying position, so I just like flying over them. It's just so fun hearing the piano. If I'm the only one that feels this way, I might be sounding like such a nerd right now. It's fun. It's fun. Anyways, I do hear a blue shell. Not the best position. Somehow I did not fall off there. Thank you, game. Honestly, that was a pretty good place to get blue. I think it worked super well. I was not expecting it to. I was expecting to fall into the pit and then have Lakitu to come, but oh, thank you, Boo. I really need to use that coin so I don't get another coin right here. But no, the game just wanted me to get another coin. We are way ahead of everybody, at least. I do see Donkey Kong a little bit farther behind me. I don't think he really has any way to catch up to me unless I keep getting hit by these blue shells. I might be able to outrun it. But no, we get hit by lightning into the blue shell. Absolutely perfect timing. I'll take it. Not the worst thing in the world. And now for our 28th race, we have N64 Yoshi Bound. Now, I have really cool memories of this one. Because fun fact, a while ago, I think it was like a couple years ago at this point, I was in an Alpha Rad Mario Kart tournament. Obviously, I wasn't the best in the world, but this was the final stage of that Mario Kart tournament. And my team went, I think there were like technical difficulties that kind of helped us win. Not gonna lie. It was cool to have the perfect countdown around that fun. Anyway, that is the general path.
Seize the sky!
This is the path I pretty much never take when I play casually, at least right in the speedrun. But you just want to get a really good grip, then use it right there. If you do it correctly, you're not going to fall off.
There are a few interesting trinkets here.
If you're not careful, but in general, not too bad. And we do have very good items, which will come in handy with this red shell. And I also do see a blue shell. You know, you gotta love it. I wonder what is the most amount of blue shells that have ever happened in a Mario Kart race. I don't think I've that unlucky, but speaking of unlucky, I almost got hit by a banana on that, if you saw it. Would not have been good, but okay, we're making it to the end. We get a double item box. By the way, one thing you might see is if you actually press L before the item box ends, the items down. Weird with how it works. Sometimes it works right away. Sometimes it takes a little longer. But you can get your items faster, so if you're ever chased down by a red shell or something, that's something nice to do. And there we go. Another win. And King Boo won this one. You know what I'm saying? Won this one when by win, I mean second place. But to be fair, for the CPU, second place is basically winning. They're not going to beat me, I'd say, as I've already lost a race. Anyways, on to TS TikTok Cloud. Another stage that is cool, but it can go very badly. There are these clock things which can very easily get in your way. What I want to do is charge up one of my boosts and not get hit by a red shell right there. I would have had a very good boost if that red shell didn't happen. But we don't actually want to take the glider part right there. Instead, we just get a couple of jumps, and there's going to be a red shell. I don't have the best angle there, but that is fine. We can make it in front of Licky too. Not the worst first lap. But yeah, I just want to make sure I'm dodging all the things, which they can be very annoying. Like right here, you never really know where it's going to be. I mean, I guess if you're really good at this game, you probably would know. But I get the good boost that I was going for last time. We also get Squidward trying to do his thing, but it doesn't really matter. I jump through here. We have tons of speed going in there. And then, okay, what was that drift? Sometimes I'm really good at this game, and sometimes I am not. Anyways, we're going to get a really good boost into this section, which is going to give us tons of speed, especially in your straight section. Now, for last lap, things have been going pretty good. Not the best. Honestly,
come a little closer. You're in for a little shock.
Get the nice boost there. We're going
come a little closer. You're going to not avoid.
I want to charge up again. I think I have a good enough angle. That way we can get the pace up. Perfect. And we made it to the end. That's
Let's dance.
Which means we're on to race number 30. And this one's going to be 3 guests on a landslide. And this is also a very difficult stage to win the CC. The biggest reason for that
come a little closer.
Whenever a stage is tight to win the CC, it's so easy to run into things, so it definitely makes it a bit difficult. But as long as we're playing well, it should be fine. Right there. Make sure I don't have too much speed. That way I don't fall into the goal. And I mean, I may get hit by something there.
What the hell are you doing when you're all on your own?
Also want to take a good trip. Nice boost right there. They can do that. And oh, I actually got the
come a little closer.
I have never actually used that shortcut before, I'm pretty sure. At least not until this stage. Okay, pretty good with that. I just want to make sure that
you're in for a little shock.
And we're pretty much always taking the right path, and oh my gosh, that red shell. Now, like I said, I want to slow down a little bit because I don't want to fall off. I don't want to get all mixed up, so we will break a little bit just for that section. And now we have a bomb. I don't love the bomb just like usual, but I mean, it's better than nothing. I accidentally threw it forward because I was trying to get that double item block. That would have been very funny if my old bomb hit me, and also very sad. I guess it has been an hour so far since I started the speedrun. Yeah, I wasn't joking when I said this run would be at least 3 hours. But pretty good. We can make it through this section. It's always nice to take. I do get hit by that wall. Not my favorite wall in the world, but I can get a boost right there, which gives a bit of extra speed. There is going to be a red shell right at the ending, and I do not know what that drift was, but we're not going to talk about it. We made it to the end. We completely demolished all the CPUs. Still up to see it. Next up, we have the Rumble Volcano. This is one of the best stages in Mario Kart, I will say by that. I mean, in general, I really like Mario Kart Wii, and I also really like Mario Kart Double Dash. Those are the ones I grew up with, so I'm always going to love those stages. But this one is just such a cool stage. It's a really cool environment. And also, if you remember during the Wii days, there was a really cool skip you could do for this track. I remember when I was a kid trying to do that skip, and the first time I got it, it was just so big. Obviously, you can't do it in this game because they were too dead. But yeah, that's
come a little closer.
So good to get. I don't really know the exact reason why it works, but I mean, it was cool. Anyways, for the actual race, we want to take a pretty standard path. One important thing is we do want to take this jump path, just so we can skip all that other stuff. The less I have to drive in this stage, the better, especially because it is slowly crumbling, as you can see. 4 parts of the stage every lap are going to get taken off, And that's just one of the things that makes it amazing. We will get a blue shell, which I don't love, but there's also going to be a red shell. Hopefully the red shell hits me first, but it actually hit my banana. I wasn't really thinking through that. That's okay though. Same path and also a lightning, but at least I can get this double item box. That's going to give me a horn, so if we do see another one of those blue shells, at least we have something to protect ourselves. I mean, I guess I'll take it. Unless we get more lightning, which definitely could happen, but I will make it through these fire guys. They're a little scary, and we're kind of going to the off-road, but not the worst thing in the world. That's another one. And next up, we have the N64 Rainbow Road. Now, this is probably the easiest Rainbow Road, but that doesn't mean it's an easy stage. Especially on 200cc, there are plenty of things that can go wrong, especially at the end. But the nice thing about this track is you get huge drifts. Like, you get to drift for so long, it's super boost. And also for that chain chomp, you always want to go over to the right side. It's super easy to get hit by it. But just look at these drifts. I mean, you just go for so long. It feels really good. We get the pink one. Finally, we release it. Get tons of speed. We get 2 more chain chomps just bouncing their heads. But, okay, that wasn't even the hard part I was talking about. And of course, we also get hit after that. But that's fine. It's okay. Now, we do have a coin. Honestly, not the worst thing to have, because hopefully we'll get some sort of protection item out of one of these item boxes. And we go in for another huge drain, another blue shell. Thank you, game. So what you want to do for this part, as I was trying to say, is you don't want to get the full pink boost. Otherwise, it's going to be too much. It can actually mess you up. And coming in at the end, can I hit with the... Oh, try to hit the person at first with my red shell, and then as karma, I got hit by a red shell. Love to see it. Now we have GameCube Yoshi Circuit, and this track is really good since it has some good shortcuts. The first one I'm going to try to do here, I kind of lost some of my speed, so it might not work, but you can actually make it over there without using the mushroom on 200cc. Hopefully I'll get it for lap 2. Lap 1 wasn't my best try. And then after that, we'll come through here. 200cc on this map with all these sharp turns is kind of hard to control. But you can also hop over that, just giving us a little bit of extra speed. And those are the 2 main shortcuts that we'll be doing for this track. So I'm going to go for this again. I want to get a good amount of speed, not slow down, do a hop, and we just are barely able to make it to the other side, which lets us skip an entire turn, so it's definitely worth it. That's also such a fun skip to do in Double Dash. You do actually have to use a mushroom to that game. But this one is so much harder, and hopefully we can get it a third time. I do got a banana right now, so we're in a good spot. That is a little too much speed. I kind of crashed into there, and okay, we got 1 out of 3. At least maybe the red shell misses me. Of course it doesn't. And there's also a blue shell coming. You know, this was not my best performance ever. I'm just happy I hit it once. And another red shell. At least I had a banana at that time. But this game just allowed me to play the game. That should be everything that's trying to murder me. And I thankfully did get a banana. The game wasn't like, here, have a coin for once in my life. So there we go. Oh, and actually Pauline is rising through the ranks. I didn't even realize Pauline was second. Donkey Kong is definitely going to have to catch up. But now we're on to Excite Bike Arena. This map is really cool because every time it's going to change its layout. It's just like Excite Bike. I remember actually playing this on my 3DS. Well, the original Excite Bike, obviously now this one. And yeah, but it's pretty simple. It makes for a simple track as well. But it means you get to do a lot of tricks and all these different jumps. So a pretty fun track too. It does look like, of course, we have another blue shell. How many of these matches have I not gotten a single blue shell? This is a short track too. You think that they wouldn't have to come every single time? At least we have something to protect ourselves from that red shell. And also, over those mud puddles, we can jump over them. And like this grass, it's not really a grass, it's kind of crazy. Super gravel. See, you just have to play it fairly well. And there we go. That's the one.
Come a little closer.
And this track is one of the hardest for me, especially on 200cc, just because of all these tight corners you have to worry about. There is very little space to do things. It comes things like make it through there. That was actually a really in which Donkey Kong, that was embarrassing. He just ran into the wall. Come on, man. Like, trying to so tough in this game. Okay, well, I ran into the wall too. As soon as I'm trying to do that, of course I run into the wall. You'll love to see it. But like I was saying, a bunch of tight turns that you have to take, so we really have to use our brake button a lot in this stage. Otherwise, we're going to run into the grass like there. Once you get to the last part, it becomes a lot easier. Like, there's plenty of...
You're in for a little shock.
This grass section, we're holding up going out and taking the left
You're
path.
in for a little
That's
shock.
it. So it's really just the first part that I find difficult. I do love the music in the stage, though. I think it goes really well with it. It's the general vibe of it. I don't love yet another blue show coming. Can't outrun it. Can you finally outrun a blue show? No, there's a red show. And then also a blue show. And somehow
Come a little closer.
I
Strike
can have that many smoke frames, but then there's lightning, so it really better. Oh, Mario Kart, I love it so much. Never page. But there we go. We just barely beat Pauline that time. That was close. Which leads us on to Mute City. And the big thing about this track, obviously, is the music is amazing. I mean, the track's good in itself, but the music in this track is really what makes it special for me. I love this music so much. And there are some tight turns in this one as well, but they're really not as bad as Dragon Driftway. And we can also go on those colorful things, and that will give us some points. So we can very quickly get up our point counter just by using that. And then we'll try to come through here. Of course, Donkey Kong hits me. Dude, why?
A slash.
I was kind of cheering for you to beat Pauline, but then you do that. So I'm gonna have to hit you back with a red show. And I love all the just the speed you get in this course. It's a very action-packed one, so I do enjoy that. But like I said before, the music is really what takes us up a notch. Now we have 10 coins, we have the coin, we have Pauline trailing with a red shell. Of course, I get hit by the red shell, but then I also lose my coin. So I can't even get a better item box. At least there was a double item box.
This team should be strong enough.
Get at least one thing that's good, and it gives us a boomerang. I tried to hit Pauline with the boomerang and ended up accidentally using my red shell, but we were able to throw it backwards, so that's nice. The boomerang, that might be the first time we actually saw it, but of course you get to use it 3 times because it's a boomerang. And
what?
Coming off on the end, Squidward, that is some terrible aim. Of course it takes me out.
Plunge!
Squidward's aim is actually really bad.
Well, now I gotta use my freaking
If I die because of it, I'm just gonna finish out with
canyon.
so not too bad. Next up, onto the Triforce Cup, we have Wii Warriors Gold Mine, which this stage, very nostalgic for me. I remember back in the past, me and my friends used to actually play hide and seek on this map, because you can get into some really weird areas, at least on the Wii version. I'm pretty sure in this version, the two will stop you from not supposed to. But you can go on like those wooden beams throughout the map, it was really cool. I recommend trying it out. But what we're going to do is actually take the right path here. You might think it's faster to take the left path, but even though it does have those boosts, those don't really help us out. And we have the easier path taking the right. Now we have some good speed going forward. There aren't really even any skips for this track. It's just about playing well. And of course, getting as many points as possible. I also don't like those bats coming through. I don't think I've ever actually gotten hit by one of them, but they're always a little scary, man. And I just want to play this well. Perfect. Thank you, Mario. I appreciate that. And then we will take our second lap. Still playing pretty perfectly. We haven't gotten bad luck. Haven't gotten a single red shell or a blue shell. There is going to be a Squidward here, but that's not the worst Squidward in the world. As long as I can still see the center of my screen, I will take the Squidward. And I didn't even know one of those bats could hit you. And also, I'm seeing shell on the back. Why did I say I should wait until after we're actually done. Maybe we can run it, but I don't think we're going to have enough speed. And yeah, this is not the blue shell red shell combo. The blue shell lightning combo.
Strike cloud confirmed. No turning back.
Now I'm registered 8 times for the best rainbow road. This one is a very simple map, but it's extremely fun, especially after you see super fast and just destroy the CPU on this map. So you just want to play it pretty well. I'm trying not to get hit by this a lot. They do some stuff you can turn audio for the most part. I'm just going to switch on that music. I don't want to you just did not get
Target punishment.
driving already. We're completely ahead of everybody else. And maybe this is the map where we have some that's what's down. And it looks like maybe Rosalina is
Where do you think you're going?
get a bullet bill or something that causes you to go extremely fast. But that's going to allow for a fucking my goal really is to get a lap plus I think that's kind of gonna make our
But we'll
back. Not good for me because as at first I'm going to have it for a very long time. I see Baby Rosalina and Baby Mario right there. Just let me get one of them. Literally right in front of me. And I think I beat it. Let's go. I finally did it. I allowed a single person of the hard CPUs. Let's go. That's time for Ice Ice Outpost. And at this stage, we want to take the green path. Donkey Kong also wanted to take it and knocked into me. But we're going to start out taking the green path, and then we're going to go onto the yellow path and not get hit by that green shell. Donkey Kong, I saw you looking at me. But switch back onto the green path, do a trick right here, and get back onto the yellow one. At least that's the way I'm comfortable with doing it. I'm not sure if it's actually faster in any way, but it's the way that's always been easiest for me to do, and I also have 2 red shells, which is nice, and they also have 2 red shells. I'm not sure if it's the second one, but we will keep this out, and we also got a banana. We're getting super good item luck this run, and not getting tons of points for no reason. But here I accidentally went onto the green path and got hit by lightning, so there goes my item luck. You know, it was nice for a little bit. It's nice to dream, at least. It's nice to think, hey, maybe I'm not going to get tons of points for no reason, but I'm full up on 10 coins. And there's the blue shell.
Thank you for
Of course,
completing.
all it gives me is a bomb. What am I supposed to do with the bomb against the blue shell? Probably not much. And in general, the bomb is pretty volatile, as I've explained before, but hopefully I just won't have to use it. We do get a point here. I would like a different item other than the bomb, but just for safety purposes, and in case we get a red shell, I am going to keep it, and it looks like that should be fair. We will drop it. Hopefully it explodes into anybody, except they're way too far behind me. And there we go. Another one done. And this is the Triforce Cup, so you already know they have to end it with Hyrule Circuit, which is an amazing stage, just because I'm a huge Zelda fan. Little known fact about me, but The Legend of Zelda is actually my favorite series of all time. I love pretty much every Zelda game. They're just all so good. And that's not really showing with that driving, not exactly sure what that was. So what we can do right here is actually jump over that grass, and that saves us a little bit of time, so that's going to be a tiny skip. Well, all the different things they added to the map, like instead of the coins, they have rupees. Anytime you get an item box, it plays a different sound. It's just all so good, it comes together great. I wish we got a win with the map or something like that. That would have been really cool. But even this, it's amazing, and it got linked in the game, so you can't really complain. Now we're going to try this turn to be a little bit better. I just want to make sure I have a good angle, and yeah, it's that easy. I'm not sure why I messed up so much on the first try. There is also going to be this blue shell. The red shell thankfully got destroyed, so good timing on that. And that is 2 laps done. We just have to play fairly well for the last one. I love this moment where the music starts picking up. It becomes really exciting now. And just one more time with this turn. This turn is always a little bit hard, but that was at least better than the first time. You know, not amazing, but better than that. We'll do the hop one more time. Able to clear all that distance. There's going to be a red shell coming behind me, but I have both the shell and the banana, so we should be good to finish out the Triforce Cup. Now for the Crossing Cup, of course, it's going to start out with GameCube Baby Park, which you already know this is one of the best stages. It's, first of all, it's Double Dash. You already know how much I love Double Dash. And we have a cool strategy where you can actually cut these corners and somehow your boots. So you want to boost over, then you
Rain outlines your face.
Side over and over again. You go so fast. It's actually insane. I never about this. I wish I did.
Right here. Right now.
The nice thing about Baby Birthday,
I hear everything.
Nice. But other thing about Baby Birthday, you never know how far ahead of you are. I was talking about laughing to see you. But
right now.
Definitely laughing now. But you just never know. Like, you'll have to go on someone to skill first. It doesn't look like it, surprisingly. And it doesn't look like it as soon as I try to do my final turn.
I'll approve you.
Red shell.
Emerge. Right here. Emerge. Know my soul.
I do not know how
Rain
far
outlines your
but
face.
and that's how this one
Right here.
starts out with a couple of turns like this. Pretty simple turns, all things considered, except for Pauline trying to crash into me over and over. For that
Let's nip that in the bud.
Actually go into a drift over get on that ramp. This one we already have to set up. That lets us go a little bit faster. And this ending part of the stage is always the part that's hardest for me. Because there's the chain drop right there. And also on the but the chain drop was and then on the top. Thank you, Pauline. I really did that. And then why are there so many fireballs? Please. I'm trying to go faster, man. Okay, we can't catch up. I know I'm just trying to go fast and actually speedrun the game, but I also got pretty competition. I want to gain this whole second place.
Rain outlines your
Really
face.
bad when you think about it. It's not going to change my speedrun time. But
Right now. Right
there we
here.
go. That was a much better turn. Maybe it's a job not just completely getting destroyed. Pretty bad things right there. Kind of in terrible places. And I was getting hit by a red
Right
zone.
now.
Then protect myself, so we are then first will come around here to get a double item box. So I'm just get rid of my coin because my coin counter is very low since I get hit by so many things. But then there's also a lightning. Another lightning. There's a that.
I just realized.
Double item box kind of missed it. Please just
Never mind.
don't be a coin game. Of course you're a coin. We finished now. I can't complain too much. Now we're on to Wildwoods, which is such a good thing. First of all, Shy Guys are amazing, and this entire thing does center around Shy Guys, which I really like. And just the environment is so nice, the music is so nice. Love hearing the Shy Guys in the background talking as the music goes. It's awesome. But okay, for this one, this is a good section where I can get a couple of coins. Missed most of them. We want to get a couple of tricks off there. And we're not going to take the shortcut because it's pretty much just as fast to go this way. Technically, it would be faster to take the shortcut if you, well, a little too risky for me. So we're just going to keep taking this left path, go through there. See the Shy Guys swinging. They're just having a great time. I don't know if they're paid by the Mario government to do this, or if they're just like, why are all these people racing literally in our town, destroying the environment, using terrible things like bombs on our places? We're probably not the best people in the world. But that's also not really my problem. It's kind of the Shy Guys' fault. I mean, they were the ones that signed off on this, but there is going to be this blue show. Not the worst place for it to happen, especially with a red show, but another red show coming after me. Thankfully, I do have that green show. I was a little worried about that one. And coming to the end, we get a coin. Literally the worst thing I could have gotten, especially with a red show right there. I was hoping I'd make it for it. And another red show. I thought Paulie right there timed those perfectly to be able to take first place for me. I would be upset. And now we have the Animal Crossing track, which is a really cool one since the season around it can actually change. The one we got this time is the fall season, which pretty much any season I will take unless it's winter. The only reason I don't like winter for this map is because it has more slippery physics. So that's always not the best way. Mario Kart track. The fall, we will take that. I mean, it's also a great one for the place. And we'll make it through there. Pretty simple track, all things considered. And it is kind of funny how you go from really hype music to just this, which is the calmest music in the world. Like, this isn't exactly what I would call race music, but I guess it is Animal Crossing. And what music is going to be race music for that game. And, you know, I'm going to music on that one. That's why I just went off the path so terribly right there. Oh, by the way, you see Mr. Rossetti on this map? I love Mr. Rossetti. Did anybody else on Melee for the GameCube, you would get the Mr. Rossetti trophy, and then if you reset your console, he would get so mad at you. I know he also did that on the original GameCube Animal Crossing, but I remember specifically doing it on Melee. I could be misremembering this, though, so let me know if anybody else remembers doing that, because I also remember there's like a playground rumor where if you did that, then you would get him as a character. Obviously, that part wasn't true, but yeah, I'm not sure if this is made-up lore or real lore. Now we the last of the original game. Before we get to the DLC, this is going to be the Bell Cup, and we start with 3DS Neo Bowser City. This is a pretty cool track. I do like the environment with it, and there is some fun spots where you can get a really good drift and just go super fast. But this part is a little bit hard, because what you want to do is not get too good of a drift, otherwise you're just going to fall off the edge, like I did right there. That wasn't the way I was saying I was going to, but you know, we're going to say that was on purpose. We saw the red show going through, it definitely wasn't on purpose, but we can act like it was. You know, maybe the red show would have been even worse. Right there, you can get an insane drift to make it over there. There are some turns in this map which make it kind of difficult. It's really interesting in 200cc, because when you're playing 150, you pretty much always want to get the best boost off of the drift as possible. But for this one, if you get a really good drift, it can literally kill you. But I will go ahead right here. We'll get the pink one, because it's just going to be a straightaway. We get tons of speed. That's going to be nice. And I see a blue show coming behind me. Of course it is. And I would love to see that. Is Donkey Kong or Paulie going to take ahead of me? It looks like they weren't able to. You don't take that. I was just that far ahead of them. But you also see Peach all the way in the back. A lot of the times with these hard CPUs, for some reason, there's one CPU that's just terrible at the game. I mean, I guess they're trying the best, man. But we should be able to end it off. Of course, there's a red show in the worst spot. You know, that's not fun. There goes Donkey Kong. I saw him emote on me. So there, yeah, taking that first place for me. I mean, fine, dude, I know you're trying to do Paulie. I don't think you're going to be able to. Next up is GBA Ribbon Road. And I know I've been saying I like a lot of the tracks in this game. I don't really like this track. I mean, it's alright. It's not the worst track in the world. It's got some cool parts. Like this part, I do enjoy. It's pretty fun to race over. And once you get to this next part, which we're going to get stopped by a red show, but I do take out the banana. Okay, that was fine. But as I was saying, I don't like